Okay, we're going to take a look at the Module 2, Lesson 2 video solutions here. First thing I want to quickly review, this is about solving absolute value equations. So remember that whenever we have an absolute value expression equal to a number, we're always going to trade that for two regular equations, right? We can't really do algebra with absolute values. We need to first make a trade for non-absolute value or regular equations. Okay, the first step is always going to be, though, we may have to do some algebra to get the absolute value by itself on one side of an equation. And then we'll always just make this trade. Whatever's inside the absolute value bars, we're going to set that equal to positive C, or we're going to set it equal to negative C and solve both of those individually. Okay, so here's an example, really simple one here. We've just got an absolute value of x is equal to 2, so we can do this one pretty quickly. We know that we're going to make the trade then because I've got the absolute value bars already by themselves on the left side. Whatever's inside, which is just an x, I'm going to set equal to 2, or I'm going to set it equal to negative 2, and those are my answers. Now notice here that they just want us to, if multiple solutions exist, which of course they do, separate the solutions with commas. And we're just filling in the blanks, so we've already got the x equals. So all we really want to do here is just 2, comma, minus 2, doesn't matter what the order is. And there it is. Okay, so same kind of thing here, slightly more difficult still, not too bad. We can see we've got the absolute values already by themselves on the left side. So we can take whatever's inside, which is the 2x. We're going to set it equal to positive 10, and we're going to set it equal to negative 10, and we'll just solve both of those. So we're just going to get x equals 5 or x equals negative 5. It's kind of a bad 5. That's supposed to be a 5. There we go. Okay, same kind of thing, only this time, this is a little tricky in a sense. You kind of have to be careful with this. You always want to make sure before you start on something like this that the equation is even going to have a solution. Now think about this. We've got the absolute value of negative x. Sure, what's inside is negative, but it really doesn't matter because the output of an absolute value function always has to be non-negative. It could be 0, but it can't be negative. And so the solution to the equation, the absolute value of something, and honestly, we don't even really care what it is. We can just ignore what's inside. If the absolute value of something is equal to negative 5, well, that's not going to work. The absolute value has to output something positive, and so the answer is no solution. Oops. This time, we've got the absolute values by itself on one side, and so look what we've got here. We've got whatever's inside, 2x plus 22, is going to be set equal to 0, or negative 0, but that doesn't make any sense. 0 doesn't have a sign. So these are really the same equation, and so there's only going to be one solution this time. I subtract 22 from both sides and get 2x equals negative 22, divide by 2, and we get x equals negative 11, and that's it. another similar example. We've got the absolute values by themselves, so whatever's inside we will set equal to positive 16 or its opposite. And we'll just solve both. Subtract 10, get negative 2x equals 6. So then if I divide both sides by negative 2, x equals negative 3. Or subtract 10, negative 2x equals negative 26 divided by negative 2. So negative over negative is positive, so I get x equals negative 3 or negative 13. You could always check these, and on a test you should. Plug these back into the original equation, just make sure that they work, that they satisfy the original equation, meaning that they make it true. So negative 3, 13. All right, for the first time, we're in a situation now where we need to do a little algebra before we can make our trade of the absolute value equation for two regular equations. We've got to get the absolute value by itself on the left side of the equation, and so that means we've got to get rid of this 10. So we'll subtract 10 from both sides first, and that's going to give us, up here, how about, absolute value of negative 3x minus 30 equals 60. So now we can make our trade. We've got an absolute value by itself, and so whatever's inside we'll set equal to 60 or negative 60. So we add 30, get negative 3x equals 90, divide by negative 3, and one solution then is going to be x equals negative 30. On the other side, if we add 30, we get negative 3x equals negative 30 divided by negative 3, so we get x equals positive 10. Okay, got another example here that's going to require a little bit of algebra before we can make our trade. Now we got to make sure we do this in the right order. Remember that when we're trying to isolate something, anything, in this case we're trying to isolate the absolute value. So when we want to isolate the absolute value, remember how we determine the order in which we do the algebra steps. We're going to take our order of operations tree, and remember that, this is the good old please excuse my dear Aunt Sally, but remember I always write the M and the D next to each other and the A and the S next to each other because those are equivalent. Multiplication and division are on equal footing, and so are addition and subtraction. So when we're trying to isolate, remember that we're going to work up from the bottom. Isolate or solve for something. So we're trying to isolate the absolute value. So we've got to undo all the stuff that's being done to the absolute value that's on that side of the equation, on the left side of the equation, in this order. So first, outside of the absolute value bars, we want to undo any addition or subtraction. So that means we've got to add 3 to both sides. So those go away and we end up with, let's go up here, we get 4 times the absolute value of negative 3x plus 9 equals negative 8. And then the next step would be we're going to divide by 4. So then we get up to multiplication division. So divide by 4. And then we end up with the absolute value equation, the absolute value of negative 3x plus 9 equals negative 2. Okay, so what do we do with that? We've got a problem, because now we can see that we've got an absolute value expression which is equal to a negative number. That's impossible. So the answer has to be NS. No solution. Same kind of problem. Once again, we've got to get the absolute value bars by themselves, And so we're going to first undo any addition or subtraction, just like before. So we'll add 8 to both sides. When we do that, let's go ahead and move up here. We end up with negative 4 times the absolute value of 4x plus 44 equals, what are we going to get? Negative 336. Okay, so next step, we're still got to divide both sides by negative 4 to get the absolute values by themselves. And when we do that, we end up with the absolute value equation, absolute value of 4x plus 44 equals, now negative over negative is positive, and so this is going to give us, what, 84? And so now we can make our trade. Now we've got absolute value bars by themselves on one side, so whatever's inside we can set equal to 84, or we can set it equal to negative 84. Now it's pretty simple algebra. I just isolate x in both of those equations. So we'll subtract 44 and get 4x equals positive 40. So if I divide both sides by 4, I get x equals 10. Over on this side, negative 44, negative 44. 44's cancel. We get 4x equals negative 128, which means if I divide both sides by 4, that x is going to be negative 32. So those are our two answers. Another example, absolute value bars are already by themselves, and so we've got, let's go up top here, we get whatever's inside, negative 3x plus 7 either equals 4 or negative 4. So just subtract 7. We get there negative 3. So we get x equals, if I divide both sides by negative 3, whoops, it's kind of messy, we get 1. Yeah, and then on this side, let's go away, negative 3x equals, if I subtract 7 from negative 4, I get negative 11. Divide both sides by negative 3, and I get x equals, negative over negative is positive, but I can't reduce that fraction. So that's our other answer. I can't, 3 doesn't go into 11 evenly. So, or there's no common factor of 3 and 11. So we end up with 1, 11/3. Okay, a few more to go. Okay, this time to get the absolute values by themselves, I've got to first divide each side by 2, and then I end up with the absolute value of negative 5x minus 3 equals 12 divided by 2 is 6. So now I can make the trade. What's inside negative 5x minus 3 either equals 6 or it equals negative 6. Just solve them both. Add 3. Negative 5x equals negative 5x equals 6 plus 3 is 9. So if I divide each side through by negative 5, that doesn't reduce, but I don't want to leave the negative on the bottom. So I'll rewrite that as x equals negative 9/5. I could put the negative on top, but I don't want to leave it in the denominator. That's not good form. It's not simplified. So there's one answer. Over here, add 3, and we get negative 5x equals negative 3. Divide by both sides by negative 5. X equals negative over negative is positive 3/5. What is that, 3/5? Yeah. How many more? Okay, 2 more. So this time we got to get the absolute value bars by themselves, which means I'm going to have to add 10 first and then divide by 2. So adding 10 to both sides gives us, we'll go up here, that gives us 2 times the absolute value of 6x minus 10 equals 10. Divide each side by 2, and I get absolute value of 6x minus 10 equals 5. And so now we can make our trade. We got the absolute value by itself on the left, so whatever's inside equals 5 or negative 5. Add 10. 6x equals 15. Divide by 6. And so I get x equals 15/6. That can be reduced. 3 goes into 6 and 15 both. So I can make that x equals 3 goes into 15 5 times, goes into 6 twice, and now I can no longer reduce that. So there's one simplified answer. On the other side, if I add 10 to both sides, I get 6x equals positive 5. Divide each side by 6. And we get x equals 5/6, which is reduced. Okay, last one. This time the absolute value is already by itself, so we can just set whatever's inside the absolute values equal to 6 or negative 6 and solve. So subtract 7 5x equals -1, so x equals -1/5. Subtract 7 from both sides over here, and we get 5x equals -13, divide by 5, and I get x equals -13/5, which cannot be reduced. So, that's it. Got it.